Hey everyone, welcome back to my YouTube channel. Our solar system, a familiar cosmic neighborhood, often feels like a well-charted territory. From the fiery embrace of the sun to the icy, distant realm of Neptune, we've mapped its planets, observed its moons, and even sent probes to touch its furthest reaches. What if this apparent familiarity is merely a veil, hiding a colossal secret, a ghost in the cosmic machine? What if, lurking in the profound darkness beyond our known worlds, there exists a planetary giant, a lost world whose gravitational whisper subtly shapes the orbits of distant icy bodies, hinting at its unseen presence? This is the tantalizing mystery of Planet 9, a hypothetical behemoth whose existence could rewrite our understanding of our own cosmic home. Act 1. The anomaly. Imagine the solar system as a grand celestial clockwork, a beautifully intricate dance of planets around our star. For centuries, astronomers have meticulously observed and calculated these orbital ballets, finding remarkable order and predictability. Yet, as our telescopes have grown more powerful, peering into the deepest, coldest reaches of this system, we've begun to uncover anomalies, subtle discordances in the cosmic symphony that defy easy explanation. Beyond the orbit of Neptune lies a vast, frigid expanse known as the Kuiper Belt, a donut-shaped reservoir of icy bodies, remnants from the early days of our solar system's formation. Here, trillions of comets and dwarf planets drift in a slow, silent procession. For the most part, these objects behave as expected, their paths influenced primarily by the sun's gravity and, to a lesser extent, by the gas giants. But among this icy multitude, a peculiar subset of objects, known as extreme trans-Neptunian objects or ETNOs, has presented a profound puzzle. These are bodies with highly elongated orbits that take them incredibly far from the sun, sometimes thousands of astronomical units away, before swinging back in. And it's their collective behavior that has ignited one of the most exciting astronomical hunts of our time. Observations have revealed that the orbits of these extreme TNOs are not randomly distributed, as one might expect. Instead, their aphelia, the points in their orbits where they are furthest from the sun, tend to cluster in a specific direction. Even more strikingly, their orbital planes are also tilted in a peculiar way, all pointing roughly towards the same region of space. It's as if an invisible hand is gently, but persistently, tugging on them, herding them into these improbable alignments. If these objects were merely subject to the gravitational forces of the known planets and the sun, their orbits should be spread out far more uniformly. The statistical probability of such a clustering occurring by chance is incredibly low, so low that it screams for an explanation. This orbital anomaly, this gravitational whisper from the cosmic void, is the core mystery. It suggests the presence of something massive, something unseen, a gravitational shepherd influencing these distant wanderers. It suggests a lost world, a ninth planet, patiently orbiting in the dark, waiting to be found. Act 2. The first clues. The idea of an unseen planet lurking at the edge of our solar system is not a new one. Indeed, the history of astronomy is punctuated by the search for Planet X, a hypothetical body whose gravitational influence was invoked to explain observed discrepancies in the orbits of known planets. The most famous early instance of this quest was in the late 19th and early 20th centuries, when astronomers, most notably Percival Lowell, sought to explain perceived irregularities in the orbit of Uranus. These efforts eventually led to the photographic discovery of Pluto in 1930 by Clyde Tombaugh at the Lowell Observatory. However, it soon became apparent that Pluto, a relatively small icy world, was far too diminutive to exert the gravitational pull needed to explain the orbital anomalies of the gas giants. Its reclassification as a dwarf planet in 2006 underscored this point. The initial Planet X that led to Pluto's discovery was a case of mistaken identity, a smaller mystery solved, but the larger gravitational puzzle persisted, albeit with less urgency for a time. A modern chapter of this hunt began in earnest with the discovery of Sedna in 2003 by Mike Brown, Chad Trujillo, and David Rabinowitz. Sedna is a dwarf planet with an incredibly elongated orbit, taking it from about 76 astronomical units from the sun to nearly 900 astronomical units at its furthest point. Its highly eccentric path, largely decoupled from the gravitational influence of Neptune, immediately marked it as an unusual object. Sedna's perihelion, its closest approach to the sun, is so far out that it cannot be explained by interactions with the known giant planets. It suggested a more distant, more powerful gravitational perturber. The true tipping point came in 2014. Astronomers Chad Trujillo and Scott Shepard published a paper announcing the discovery of 2012 VP113, another ETNO with a perihelion even further out than Sedna's. More importantly, they noted that 2012 VP113, Sedna, and several other known ETNOs all shared a peculiar characteristic. Their arguments of perihelion, a specific orbital parameter, were clustered. This was the first concrete statistical evidence of the orbital alignment that would become the cornerstone of the Planet 9 hypothesis. They suggested that the observed clustering was best explained by the gravitational influence of a massive, unseen perturber, potentially a super-Earth or a mini-Neptune, orbiting far beyond the Kuiper belt. Building on this crucial work, in 2016, Konstantin Batygin and Mike Brown, both at Caltech, published a landmark paper that brought the Planet 9 hypothesis to the forefront of astronomical research. He meticulously analyzed the orbits of 6 of the most extreme TNOs, confirming the highly improbable clustering of their perihelia and the alignment of their orbital planes. Their sophisticated dynamical